All right, this is exam 2 for Physics 101, Fall 2012. This person walks 20 meters to the west and 30 meters at an angle of 30 degrees north of west. So that's 20 meters, and then 30 meters at north of west. That's this 30 degrees. All right, so this is 20, this is 30. I can make a little table with my x and y components. My first x component is going to be negative 20. Y component is 0. This is going to be negative 30 cosine of 30. And then this is going to be 30 sine of 30. And then if I add up those, I get 20 and 30 cosine 30. That's, we'll call that negative 46. And then 30 sine of 30, it's 15. And so to find the magnitude of that resultant vector, which is right here, has those components of negative 46 and 15, it's going to be the square root of negative 46 squared, or just positive 46 squared is the same, as 15 squared, which gives me 48.4. That was keeping 3 sig figs, because that's what I had throughout. So 48.4. Number 1 is D. Consider these two vectors. Which represents the vector B minus A? All right, well, B is drawn just as it is, and then minus A is the opposite of what we have here, and so the answer then should look like that. That is going to be B for number 2. The vector has negative x and y components. All right, if it has a negative x component and negative y component, it needs to be in the third quadrant somewhere. It says the y component is bigger than the x component. That means that this is going to be bigger than this. So that'll put the vector somewhere like that. Now, to be in the third quadrant, we can just get rid of some. It has to be between 180 and 270. All right, so that gets rid of that. Gets rid of that and that. So it's either 190 or 230. But we want the bigger one because it has to be bigger than 180 plus 45, which is 225. All right, so it has to be bigger than that, so that's D. It has to be bigger than that because the y component is bigger than the x component, in which case that angle, that is this angle right here, has to be bigger than 45. It's equal to 45 if the y is equal to the x component. All right, you kick a soccer ball at initial velocity. My trajectory, 20 meters per second at an angle of 30 degrees. From the horizontal, it lands some distance away. How long does it take to come back to the ground? All right, so I can find the time required to get to the top up here. I know that v in the y direction at the top is equal to 0. So I say vy equals v naught y plus ayt. I'm going to call this t top. So that's 0 equals the y component, which is 20 sine of 30 plus negative 9.8 times t top. And then if I solve that for t top, that's going to be 20 sine 30 divided by 9.8, which is about 1 second. All right, so that means that the total time is going to be twice t top. It's going to be 2 seconds. So the answer is D for number 4 is D. Which of these statements is true for an object in projectile motion? All right, the y component of the velocity doesn't change. That's not true. If I look up here, initially the y component's big, then it gets smaller, then it's 0, and then it gets bigger and bigger. So that's not it. The acceleration in the y direction is constant. All right, that's true. The acceleration is always equal to negative 9.8 in the y direction. So that's true. Let's just go through the others. The acceleration in the y direction is 0. All right, well, that's contrary to what we just said, because it's always equal to negative 9.8. Even at the top here, the acceleration is still negative 9.8. The maximum height is dependent on the x component of the velocity. To make that true, we'd have to say the y component. All right, it's not dependent upon the x component. And the velocity of the object at the top of the trajectory is 0. That's sort of true. We could say that the y component of the velocity, but remember at the top of the trajectory, Vx is not equal to 0. So that's not a true statement because the velocity isn't 0, it's just the y component of the velocity is 0. All right, so the answer is B for number 5. Student has two vectors with magnitudes 200 and 40. So I have a 200 and then I have a 40. How can I add them together? I can either add them that way or I can add them in this way. This gives me a vector 240 units in length, and this gives me a vector 200 minus 40, which is 160. So it has to be between 160 and 240. That's A for number 6. The ball is rolled horizontally off a table with an initial speed. So I have this ball. It has initial speed, and it goes like that, just like we did in the lab. The time is 0.3 seconds. What is the height of the table? So we say y equals v0y t plus 1/2 ay t squared. v0y is 0 because I only have an x component of the velocity. So v0y is 0. I think many of you probably use 0.24 for v0y, but that's not correct. So it's going to be 1/2 of negative 9.8 times t, which is 0.3 squared. Let's see, for number 7, that gives me 0.44 meters. Okay. A cart is accelerating along a flat surface. A cannon falls on the cart, fires a ball directly overhead. Where does the ball land when it comes back down? All right, so this is my cart, and it shoots a ball straight overhead. All right, so the ball travels upward. But if this cart is accelerating, the ball, when the cart is over here, the ball is going to land behind the cart somewhere. We did this little thing in class. It's like you throw something up and then you run away. It's going to fall behind you. All right, this figure shows the trajectories of 3 punts, each of which has the same initial velocity for which punt is the football in the air the longest amount of time. All right, the one with the highest y displacement has the longest time in the air. So that's going to be A for number 9. If we know an object moving at constant velocity, we may assume that what? The object is accelerating. Okay, that's not true. If it's moving at constant velocity, the acceleration is 0. The object is losing mass. We can't assume that is true. There are no forces acting on the object. Not necessarily. We can have forces acting. Or the net force is 0. All right, so the net force, D, is 10. Which of these ideas was proposed by Aristotle? The natural condition for a moving object is to remain in motion. All right, that's not true. Newton actually said that. For every action, there is an equal but opposite reaction. Again, Newton's third law. The natural condition for a moving object is to come to rest. All right, C is the correct answer, and D is Newton's second law. So this was the first law, third law, second law, and C was Aristotle's thoughts about the thing. 2 ropes are attached to a 40-kilogram object. The first rope applies a 25 Newton, and the second 40 newtons in the opposite direction. What is the resultant acceleration of the object? All right, so I have 25 newtons in this direction, 40 newtons in this direction. This is similar to the boat problem that we had in the homework. So the net force equals 15 newtons. I want to know the acceleration. A equals F net over M. That's 15 newtons over 40 kilograms. I get 0.375 or 0.38. So E. So number 12 is E. Our worker pulls a 200 Newton packing crate at constant velocity across a rough floor by exerting a force 55 newtons at an angle of 35 degrees above the horizontal. What is the coefficient of kinetic friction? And then I gave you this hint that the normal force isn't equal to 200 newtons. Let's draw our forces. We have the normal force. We have our weight. We have our kinetic friction. And then we have this force that's applied, F. All right, this was probably the most difficult problem on the test. So if you got it right, good job. If not, don't sweat it too much. This is going to be F sine of 35. This is F cosine 35. This is Fk. This is Fw. All right, so now I can do Newton's second law. Sum of the forces in the x will give me F cosine the 35. And since it's not accelerating, the sum of these is going to equal 0, so I'm just going to go ahead and say f cosine 35 equals fk. All right, because f cosine 35 minus fk will equal 0, so I can say that this is true. And then we do the sum of the forces in the y, f sine of 35 plus fn minus fw equals may, but the acceleration in the y direction is 0, so that's equal to 0. All right, now I'm looking for the coefficient of kinetic friction. I know that fk equals mu k fn. So mu k equals fk over fn. All right, and that'll give me my answer. So I can find fk over here. It's just equal to f cosine 35. That's 55 cosine 35. And I get 45 newtons. That's my kinetic frictional force. And here I also need to find the normal force. The normal force is going to equal to Fw minus F sine 35. That's going to equal to 200, that's the weight of the object, minus 55 sine of 35. I get 170, I'll call it. So 45 over 70, over 170, 0.26. I get 0.265 of, let's see, so it should be B, number 13. Yeah, it's B. I should have kept, I should have kept 3 sig figs throughout. To be more correct, I should have had a dot right there. But it's the closest answer, 0.265. All right, a 50 kilogram woman dangles a 50 kilogram mass from the end of a rope over the edge of a cliff. What is the tension in the rope? And the woman and the mass are stationary. All right, this was similar to the tree problem where you're pulling on the rope. All right, very similar. All we need to know the tension is to know that the force weight here and the tension here, that those are equal and opposite. So the tension in the rope equals the weight of the block. So that's 50 kilograms times 9.8, which is 500 newtons. You don't need to know the mass of the woman. That's irrelevant. It's like hanging it onto a tree. It doesn't really matter. A man dangles a 10 kilogram mass from the end of a rope, steps on an elevator while holding the rope, and the elevator accelerates downward. So this is very similar to our homework problems. I'm not going to draw the guy. I have a 10 kilogram. It's downward at 3 meters per second squared. There are 2 forces acting on it, the tension and the weight. Sum of the forces in the y. All right, so Ft equals Fw plus Ma. Fw is 10 kilograms, 9.8. Plus 10 kilograms times negative 3 meters per second squared, because it's going downward. So that's 98 minus 30, which is 68 newtons, or E is 15. That was an MCAT problem, by the way, but very similar to some of the homework that we've had. A block of mass M rests on the floor of an elevator, is accelerating downward at 2 meters per second squared. All right, what is the relationship between the force due to gravity and the normal force? It's accelerating downward. The acceleration, draw 2 forces, the normal force and the weight. So sum of the forces. So the normal force equals Fw plus Ma. But remember, A is a negative number. That means that the normal force, you may just say Fn, that the normal force is less than Fw. So that is B for number 16. This figure shows an inclined plane. Block is accelerating up. Acceleration. Which of these equations is correct? I took this one out. That one is correct, by the way. Otherwise, let's just go ahead and sketch in our components here. This angle is 60. So I'm going to have Fw cosine of 60 and FW sine of 60. Those are just the x and y components of that weight. So Fn minus Fw sine 60 equals MAY. That's this minus this equals MAY. That one looks correct. Fn equals Fw. That says this equals this. They're on different axes, so that can't be true. Let me just show you this. This one was a correct answer, but I told y'all not to use it. F minus Fw cosine 60. That says this minus this equals 0. Oh wait, no, that's not correct because it's accelerating up the inclined plane. Well, I guess I didn't have to take that out after all. Okay, that's not a correct answer because it's accelerating up the inclined plane. All right, and then Fn plus F equals Fw. That says this equals this plus this. That's just kooky. All right, so the answer is A. You push an object on a rough surface. Which of these best describes the work done by the frictional force? Its displacement is in this direction, but the frictional force is in that direction, so it has negative work. Remember, work equals Fd cosine theta. Here, theta equals 180, and cosine of 180 degrees, or the cosine of pi, is equal to -1. You push a grocery cart with a force of 12 newtons at an angle of 60 degrees downward from the horizontal. How much work do you do on a grocery cart? All right, I have a force that's pushing downward 60 degrees, and my displacement is 6 meters in this direction. This is simple. Work equals Fd cosine theta. Told you you'd have one of these. Just simply plug in the numbers. I have 12 newtons, 6 meters, cosine of 60. That gives me for number 19, B. This figure shows 4 blocks, each moving to the right. For which block is the force doing the most negative work? All right, the block doing negative work is the one pointing to the right. This force is doing negative work, and this force is also doing negative work, but this force is doing more negative work because all of that force is in the negative direction. So the answer is B. 2 kilogram objects initiate rest. Push on with 12 newtons over a distance of 3 meters. What is the velocity of the object? All right, work is equal to the change in kinetic energy. All right, so my work is force times displacement. That's 12 newtons times my displacement of 3 meters. And that's equal to 1/2 mv squared. That's 1/2 of 2 kilograms times v squared. So this is 36 equals 1 v squared. Square root both sides. V equals 6. That's A. Dr. Young thinks his students are the best ever. Y'all did a great job with the food drive. I think, what did we say? We got 1,375 items total. That was for our department, but you guys brought in 800 of those. All right, and keep this in perspective. Gosh, let's see. The whole university only brought in about 13,000 items. So y'all brought in, you know, a little under 10%. Let's see, 800. All right, y'all brought in 6%, half of 10%. I think that's pretty darn good, considering that it's such a small class in comparison to the rest of the university. So A, y'all did a really great job, and this is version A of the exam. There's all the answers. That's the end.